Hello, I'm Holden Marcsisin. I go by Ospiel on the internet. You may not know me as the Windows maintainer for winit, which is the main Rust, pure Rust window creation library. We currently support Windows, Mac, Linux, iOS, and as of yesterday, we support the web. Today, I'm going to be talking about the various baffling things all the platform-specific windowing systems do that make this job hard. Naturally, since we're covering everything, this talk will be a couple hours long, so hang tight. Why isn't that working? There we go. So let's say you are designing a new windowing library. This is probably the first API you try. This has a couple of benefits. It is easy to understand. It's nice and rusty. It's easy to maintain. It's wrong. If you aren't writing desktop games, if you are writing desktop games, this mostly works fine. But then, and I'll just quickly illustrate how you use that. Your application constantly spins and looping. It starts by greedily pulling all the events out of the OS event queue. After that, you process your events and redraw your window. If you're writing a game, this is pretty much all you need to do. You like high frame rates, you're going to consume all these resources by necessity, and since games need to update at least 60 times per second. But then you get to desktop app developers, such as myself, and they start complaining that constantly consuming resources doesn't work because unlike games, desktop apps have to play nicely with other apps and make sure they have time to run their own code. So OS APIs expose functions that allow you to wait until the OS has a new event and only wake up with the program when that happens, and that works great. And from a user's perspective, this isn't all that different, but it doesn't eat all of your CPU, and your application sits in the background when it doesn't need to work. So you think you've satisfied them, but then the desktop developers ask, can I have multiple windows at once? And the previous model didn't really work with multi-window environments because you can only wait on a single window at once. So at first, you tell them to spawn a new thread for each window in which the desktop developers accept begrudgingly because they don't want to work on this low-level stuff. So you've satisfied the Windows developers. You've satisfied the Linux developers, and the macOS developers come and tell you that their program crashes when you have multiple windows. So you go ahead, you test this, and it turns out macOS cannot run event loops off of the main thread. So that is annoying, but you can work around it. But you need to go ahead and design a new API. So now you go ahead, create a separate event loop struct. All the windows reference that struct, and all the events get thrust into that event loop, and everything works fine. All of the events get delivered to one place. Everything seems to work, and then it doesn't. This time, both the Windows and macOS programmers have the issue that whenever you try to resize one of the windows, the entire application freezes. This is because Windows and macOS only expose pull events and wait events to lull you into a false sense of security. Whenever a resize starts, the OS starts its own internal event loop that only returns control flow to the main event loop when you are done resizing. You can't actually put any of your application logic outside of those functions. Instead, you have to pass a closure to the OS and put all of your code in there. So you do that, you stop using iterators, you take complete control over the event loop. That isn't particularly rusty, but Microsoft forced that on you, so you'll go ahead and accept that. But it's much less readable, but it works, and that is what matters. Then you decide to put your library to iOS, and iOS doesn't have pull events or wait events. It only has run. And we are already just exposing run. This mostly works, but on iOS, run never ever returns. So you modify your return type, it returns the never type, and it works on iOS. But then but how are you supposed to expose that on desktop? Because desktop applications like to return. I am aware of two main hacks to make this work. Either you run the OS event loop, you panic. This is obviously a bad solution, but it would technically do what you need. Then the other slightly better solution is to use process exit to abort the application at the end of the event loop, which is what winit is currently doing. Please tell me if you know a better solution. Nobody likes this, including myself. So now you've conquered the desktop, you've conquered iOS, and now you want to move on to the internet. So we port winit to WebAssembly. The problem is that in WebAssembly, run has to return always. Because in WebAssembly, the browser never surrenders control over the event loop. You pass your closure to the browser. You're running main, you pass your closure to the browser. Then you return from main, the browser intermittently calls that closure. So that kind of sucks if you want to support iOS and the web in the same API, but there's a solution. You start up, Step 1, you set the event handler, then you throw a JavaScript exception, kill the stack, catch the exception from where you're calling into winit, then return from that function as normal. And now everything works. You can compile code once and run it anywhere, and now you have to deal with graphics, which you don't have time for because I only have a couple seconds left. Thank you all so much for listening to this talk, and thank you to all the winit maintainers, because this is far more work than any single person can ever do.